Greetings to Muhammad Yusuf. So we are here, the reason we are here is to present about the BMM 3521 Fluid Mechanics Lab. So our topic for this week is about the Lab 3 friction losses in pipe. So these are our group members. We are consist of 4 members. So I myself, Kubulan Alakimania, my metric ID is MA18098, is going to start the presentation. Fluid flow is an important part of many processes, including transporting materials from one point to another, mixing of materials and chemical reactions. In this experiment, we will investigate fluid flow in a pipe network and will explore several methods: rotameter, orifice, and venturi meters for measurement of the fluid flow. In pipe flows, the losses due to friction are two kinds, that is skin friction and form friction. So these are the examples. So then the main objective of this lab experiment is to design complete measurement technique for fluid flow and determine major and minor losses in different piping system. Second one is to investigate the velocity for different diameters of pipe. Then I would like to touch about the theory, which is chapter 2. So this is the image. So when a gas or liquid flows through a pipe, there is a loss of pressure in the fluid because energy is required to overcome viscous or frictional force exerted by the walls of the pipe on the moving fluid. So this is the main equation, which is H total equals to H major plus H minor. So as we say, H is the pressure loss in pipe flows is commonly referred to head loss. It's actually similar. And in a long pipe, the friction head losses are relatively important and they cannot be neglected. Efficient coefficient process, which is known as the Darcy-Weisbach equation. So where the HF is loss of head due to friction, L is length of pipe, E is diameter of pipe, V mean velocity of flow in the pipe, and F is Darcy-Weisbach friction vector. Then this is the losses. This is the picture of shows both the losses and the type of pipe. So this is the 90-degree bend pipe. Then so losses are usually measured experimentally and correlated with the pipe flow parameters. Reynolds number. The measured minor loss is typically expressed as ratio of the head loss HM through the fitting or valve on the velocity head V2 over 2G of the attached piping system. This ratio is called the loss coefficient K for the fitting or valve. This is called the minor loss, which is the formula as HM equals to K V2 over 2G. So now I would like to let my colleague to speak about his slide. Thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh. Okay, my name is Muhammad Iqbal bin Muhammad Ali. Now I will present about chapter 3, which is method and procedure. Okay, first there are some apparatus that we use to perform this experiment. There are 5 apparatus. First is fluid friction apparatus. Second is hydraulic bench. Third is pressure sensor. Fourth is data measurement and data acquisition. Lastly, stopwatch. Okay, next I will proceed with the experiment procedure. First, all valves are open to allow water to flow through all the pipe. And second, in the fluid friction apparatus, the pump is turned on to circulate water across the pipeline. Next, the control valve is adjusted to see how the water volume flow reacts to the change. The tank is examined to determine whether there is a connection between the control valve and the amount of water flowing through it. Okay, next, to start the experiment, the unused valves were closed and the valve left across the pipe to calculate the friction loss. Okay, next, the pressure sensors are installed on the valve to monitor and record the pressure 1 and pressure 2. This experiment include a flow rate indicator that display the result in LPM units. Next, the procedure above will carry on for the next flow rate valve. Lastly, the procedure above will repeat for second experiment on another pipe and so on. Okay, that's all from me. Thank you.
Next, we will continue on the chapter 4, which is result and discussion. First, the 4.1 is the result. For the result, we can see the volumetric flow measure head loss, measure friction coefficient, velocity, Reynolds number, calculated coefficient of friction, and the calculated head loss. We can see there are 4 different table, which is first one is the straight pipe, the second one is for the elbow pipe for 90 degree, the bend pipe 90 degree, and the last one is the 45 degree. So next we go on 4.2, which is sample calculation. This calculation show how we get the data from the previous table. So for the given information is length of the pipe is 800 mm, the internal diameter is 20 mm, and pipe thickness is 1.5 mm. So for this experiment, we assume that the room temperature is 25 degrees Celsius, the density of water is 997 kg per meter cube, and the dynamic viscosity is 0.895 times 10 negative 3 kilogram per meter second. So the step 1 is we calculate the velocity for the fluid. We use the formula Q equals to V times A, which is we can calculate the velocity Q over area. Next, the measure friction coefficient. We use the formula F equals to 2H dg over LV square. So we get the measure friction coefficient of the data. Next, we calculate the Reynolds number, which is Re equals to rho Vd over mu. So number 4 is calculated coefficient of friction, which is formula used is F equals to 0.316 over Re to the power of 1 over 4. And the last one is calculated head loss. The formula is H equals to F LV squared over 2dg. So we get the all data by using this all calculation. So next we continue on the 4.3, which is the graph. The first one is the head loss versus velocity. We can see the left side is the straight pipe graph. For this graph, the x-axis is the head loss and the y-axis is velocity. The orange line for the graph is the measure head loss and the yellow line is calculated head loss. The same goes on the elbow pipe for 90 degree, which is the graph at right side. So next, we also can see the bend pipe for 90 degree and the 45 degree for the data. Next is the coefficient friction versus Reynolds number. For this graph, the x-axis is the coefficient of friction and the y-axis is the Reynolds number. For the orange line is the measure friction coefficient and yellow line is the calculated coefficient of friction. We also can see the data for elbow pipe 90 degree at the right side, and this is the graph for bend pipe 90 degree and 45 degree. So next, 4.4, which is discussion. From the graph above, we can see there are 8 different graphs for the comparison between the calculated and measured value for the head loss and the friction coefficient for all data. Both comparison and graph show the same trend, which the head loss increase along with the volume flow rate. For the friction coefficient, the graph show decreasing over the Reynolds number. We also can see the calculated values are higher than the theoretical value. This happen maybe from the lack of maintenance of the apparatus, leakage, and maybe the technical error during the experiment. Next, the amplitude of the fluid flow will increase as the flow rate is increased. As we can see, the head loss value increase as the velocity value increase. There will be some non-moving liquid in the tubing, and the inner diameter of the pipe will be reduced and the flow velocity will increase. As a consequence, as fluid velocity rises, the value of friction rises as well, resulting in an increase in head loss.
Okay, Assalamualaikum warahmatullahi wabarakatuh and a very good evening. My name is Amirul Nawaf bin Isa and my ID is MA17222, and today I will be discussing about chapter 5, conclusion. Okay, so from the conclusion we can see that as a result we were able to complete our lab goals, which include determining some of the parameters such as 1. Head loss, 2. Pipe friction coefficient, 3. Loss coefficient, number 4. Reynolds numbers, and other related parameters. Other than that, we have also studied and clarified how the various parameters influence the pipe losses. Next, we can say that the friction or added attachments and elevation changes can all cause losses during the flow of fluid through a pipe. And the pipes that we have used is the straight pipe, elbow pipe, bend pipe, and a 45-degree angle pipes, which are all used in this experiment. Next, we can say that different types of pipes with different turning radius can have a large impact on the pipe losses due to flow separation. And we can say that these losses can be reduced by choosing the right pipe sizes and fittings for a device. And that is all from me as a conclusion. And also the frequently asked questions for this lab is detailed in the report. Thank you.